Hey everybody, welcome to the Great STEM Show. I'm your host, Jeff Epps. I've got my t-shirt swag going. I got my Vans on. It is time to get the show started. In today's session, we are going to define STEM and we're going to discuss the difference between STEM education and STEM integration. Okay, so what is STEM? Well, we have to define it because when I first started Stemrel City, I realized that people don't know what STEM is. I did a lot of keyword research and the results were astonishing. So let me share them with you real quick. In Fayetteville, North Carolina, where I live, there are only 10 to 100 searches for STEM education per month. Ladies and gentlemen, Fayetteville has a potential reach of 931,000 people. But on a monthly basis, there are only 10 to 100 searches per month. That's a problem. When we look at the number of searches nationwide in the United States, there are only 1,000 to 10,000 searches per month. That's a huge problem, and that is why I created the Great STEM Show, and that is why we are going to start by defining STEM. Okay, so what is STEM? STEM is an acronym for science, technology, engineering, and mathematics. Let's start with science. Science is basically knowledge obtained through observation and experiments. And you can apply this mode of thinking. You can apply observation and you can apply experimenting to any part of the curriculum, whether it's math, whether it's science, whether it's social studies, physical education, or science. Now, if we look at math, math is the study of shapes, quantities, numbers, and spaces. We've been teaching math for years in our schools. However, when we apply shapes to other subjects, when we apply space to other subjects, when we apply quantities to other subjects, we can then begin to get the practical application of math anywhere in the curriculum or even the real world. Now, next, let's talk about engineering. Now, this area of STEM requires a little bit more explanation because in many cases, when we think of engineering, we think of an engineer. Well, an engineer is a career, whether you're an aerospace engineer or an automotive engineer. However, engineering is a process. And it doesn't matter what type of engineer you are. If you apply the engineering process, then that is the mode of thinking toward true problem solving. So when we talk about the engineering process, we're talking about defining the problem, researching a solution, brainstorming, doing development work, building a solution, and testing and redesigning our solution. And that is engineering. And when we can apply that across the curriculum, we create a learning experience that will raise student achievement. Last but not least, let's look at technology, my favorite part. Okay, so the technology in STEM deals with the exposure to hardware and software that's used to visualize math and science concepts. And when I talk about technology, hardware, and software, in many cases we're talking about the exposure to emerging technologies such as 3D modeling, coding, 3D printing, electronics, because when we can expose our students to emerging technologies, we stay ahead of the rate of technological change, which is about every 2 to 3 years. So when you take the scientific mode of thinking, the mathematics mode of thinking, the engineering mode of thinking, and mix that together with emerging technology, hardware, and software, now you're using STEM and you're applying it to student learning. So what I want you to walk away with from this segment is that it is the application of STEM that really enhances learning. STEM is not just a class that students attend. It has to be a way of learning that's incorporated throughout the curriculum. And in our next segment, we're going to talk about the difference between STEM integration and STEM enrichment. All right, so there are two basic ways that STEM can be applied to learning. It can be STEM enrichment or it can be STEM integration. STEM enrichment basically deals with students learning a type of technology such as coding, 3D modeling, 3D printing, and it's used to enhance their knowledge and skills with technology, but it is not integrated with learning. Now, there could be some indirect learning happening. For example, when students are learning to model in 3D, they are learning geometry, but the specific goal is not to teach them geometry. It's simply to expose them to 3D modeling. Or with students, whenever students learn to code, they have to learn a little mathematics because that's what drives coding. But the specific goal of the coding session is not to enhance or teach mathematics. However, with STEM integration, the specific goal is to enhance the student's learning experience by enhancing a learning objective. You pull the learning objective from your state's standard course of study or your state's curriculum guidelines, and then you build an activity that's based on some type of technology to visualize it, and its specific goal is to raise student achievement in the classroom. Now, for my parents that are out there, when you enroll your child into some type of STEM program, you want to ask that question. Is this STEM enrichment or is this STEM integration? Because you want to be clear about what's going to happen as a result from your child participating in that particular program. And I would say that STEM integration carries a higher premium than STEM enrichment because the focus of STEM integration is to raise student achievement. And now I'm going to show you an example of true STEM integration. Okay, ladies and gentlemen, now we will show you an example of STEM integration. We are going to integrate coding and use it as a way to visualize a math standard. This particular standard comes from the Common Core, and it is 6th grade ratios and proportions. And the standard reads, understand the concept of a ratio and use ratio language to describe a ratio relationship between two quantities. For example, the ratio of wings to beaks in the birdhouse at the zoo was 2-to-1 because for every 2 wings there was 1 beak. So we are going to actually use Microsoft's small basic programming language to visualize this concept. This is a free download from Microsoft, and I urge anyone to download this because it is a great way to expose students to coding. I think it's important also to point out that this is basically a word problem. We will use the nouns in this word problem to build our block of code. We have beaks, we have wings, and we have birds or the birdhouse. So we've established 3 variables here called birds, wings, and beaks. We have established a value for each one of our variables. Birds equal to 1, wings equal to 2 because every bird has 2 wings, and beaks equal to 1 because every bird has 1 beak. Now, this is where the magic happens. In line 4, we are sending output to the screen, and we are saying that the number of birds in the birdhouse is equal to the value of our variable called birds, which is 1. And in line 5, we're sending the output to the screen regarding the number of wings. And we're saying that the number of wings in the birdhouse is equal to the number of birds times the value of wings, which is 2. And then finally, we're sending the output of the number of beaks to our screen, showing that the number of beaks is equal to birds times the number of beaks. So let's run our output and see what happens. And it says that the number of birds in the birdhouse is 1, the number of wings in the birdhouse is 2, and the number of beaks in the birdhouse is 1. So we've essentially created a solution with regard to the math portion. We've integrated the technology, we've integrated the math, and we've really engineered the solution by building it. So, where does science come in? Well, we said that science happens through experimentation and observation. All right, so let's put that into practice. What if there were 13 birds in the house? What would be our number of wings and beaks? Well, we could change the value of birds to 13, click run, and now we see that there are 13 birds in the birdhouse, 26 wings in the birdhouse, and 13 beaks in the birdhouse. Well, what if there were 1,300 birds in the birdhouse? We could easily see that the numbers will change according to our input, and this is the scientific method. We're experimenting, we're observing, and this is how you implement STEM into student learning. You have an objective, a learning objective, and you use technology, science, mathematics, and of course engineering to build a solution. And it is here that the application of STEM becomes extremely important and extremely effective. Okay, ladies and gentlemen, we now know that it is the application of STEM that is so important. And when we can apply it to student learning and integrate it into student learning, that we create a learning environment that is second to none. We turn students into STEM students. We turn schools into STEM schools. Hey, I'm Jeff Epps. I want to hear your comments. You can reach out to me at jeff@stemeralcity.com. By the way, this is Timex, the Wonder Dog. He's a watchdog. Get it? Timex, watchdog. Timex is the name of a watch. Yeah, it's a nerd thing. All right, we'll see you in the next episode. Until then, get your nerd on.
Get a life, nerd.